Hey guys, Mr. Gran here, and this is 6163 review for FST. For this test, you will have to know the following: naming polynomials, naming them by their degree and their number of terms, as well as identifying degree, terms, leading coefficient, all of that stuff from 6.1. You will have to be able to add and subtract polynomials. You'll need to be able to multiply polynomials, including using Pascal's triangle type problems. You'll need to be able to divide polynomials using both long and synthetic division. All right, so let's start with these ones. So add or subtract and writing your answer in standard form. And I would add also identify the degree, the number of terms, the leading coefficient, and naming them. So take a moment, pause the video, and unpause when you are ready. Okay, when it comes to adding and subtracting, one thing for the test, make sure that you are actually adding and subtracting. It is super common for students to multiply on this one and come up with, do a lot of good math, but the wrong type of math for the problem. So really pay attention to what symbol is between these. If it's an addition one, it's literally just adding like terms, combining like terms. So I've got some squared ones that can go together. If I use some different colors here, we've got X's that can go together. And then we've got, come on. And then we've got some constants that can go together. All right, so in standard form, the x cubed goes first, the highest degree. Then for the x squareds, 15 minus 1 is 14x squared. Then for the x's, negative 3 and 6 makes a plus 3x. And then 11 plus 1 for the constant is 12. All right, now if we were to name this, if we were to identify the degree and all that stuff, the degree is the highest exponent, right? So x cubed is our highest exponent, so degree of 3. The number of terms is 4, right? Because there are 1, 2, 3, 4 separate terms. The leading coefficient is positive 2, and this is a cubic polynomial. All right, for the next one, now we're subtracting. So what I want to make sure that I do is I distribute that minus in, and that's going to change the sign of all of these. So that minus 4 is going to become a plus 4. The plus x squared is going to be a minus x squared, and the plus x is going to become a minus x. And now it's just the same thing as before. We're just combining like terms. So the x squareds go together, the x's go together, and then I just have one constant. So I don't really have to highlight that. All right, 3x squared minus x squared is 2x squared. Negative 5x minus x is minus 6x. And then that minus 4 became a plus 4 because we're subtracting it. These x's look pretty bad. X, x. Okay, degree, terms, and leading coefficient. The degree is 2. The terms, there are 3 of them. The leading coefficient is again 2, and that makes this a quadratic trinomial. All right, now some multiplication ones. So pause the video if you want to try these. Okay, so this first one I'm going to do with box method multiplication. So that x squared minus 3x and a positive 4 for the plus 4. Then 2x cubed, 4x squared, and minus 2. And I'll make all of my boxes. They don't line up perfectly. All right, so the top one here, this is going to be 2x to the 5th. Remember that you are multiplying the row by the column. So the 2x cubed and the x squared make this one, which makes 2x to the 5th. and then the 2x cubed and the minus 3x squared multiply to make negative 6x to the fourth. Then 2x cubed and 4 multiply to make 8x cubed. All right, the 4x squared and x squared make a 4x to the fourth. The next one will be negative 12x cubed. And then the last one will be 16x squared. And then the minus 2's in the bottom row will become a minus 2x squared, a positive 6x, and a minus 8. Now we're going to line up our like terms. So this one, they don't line up perfectly diagonally. The x to the fourths do, but notice that the x cubeds, there's 2 of them that line up diagonally, but then this last one here is an x squared, so that one doesn't go together. The x squareds don't line up diagonally. And those are all of my like terms kind of highlighted there. So if we're going to write this in standard form, we'll start with the 2x to the fifth. Then the 4 and the minus 6 make a minus 2x to the fourth. The minus 12 and the plus 8 makes a minus 4x cubed. The minus 2 and the 16 make a plus 14x squared. And then we've got a positive 6x and a minus 8. All right, the next one, I think this is a good one for using the FOIL method because it's a 2 by 3, but you could certainly use the box method as well. I'll start out by distributing the x into all 3 terms, and that's going to give me 5x cubed, 2x squared, and 4x. And then I will distribute the minus 1 in, and that's going to give me minus 5x squared, minus 2x, and a minus 4. Right, and then it's just combining like terms. Let's see, there's only the one x cubed, but there are a couple of x squareds, and there are a couple of plain x's. So that's all of my like terms kind of grouped together by color. 2 minus 5 for the x squareds is a negative 3, so minus 3x squared. 4 minus 2 is plus 2x, and then minus 4 for the constant. All right, dividing using synthetic division. Again, pause, try this one out, and then resume when you are ready. All right, so first step, we are going to take this x minus 4, and we're not going to use a minus 4, we're going to use a positive 4. So 4 goes in the little box. And then we are going to take all of the individual terms, and we're going to take out the x's and just use the coefficients. And if we're missing a power of x, we have to have a 0 in as a placeholder. So where it goes from cubed to the linear, there's no quadratic, there's no x squared. I'm going to need a 0 for the x squared. All right, so my first one is x to the fourth. That coefficient is 1. Then the x cubed has a minus 3. Then I'm missing an x squared, so that gets a 0. My x to the first is a minus 7. And then my constant is a minus 14. Our synthetic division steps. That first number is going to move down below the line. And then everything is going to get multiplied by the 4 to move from beneath the line to above the line. So 1 times 4 is going to be positive 4. Then we're going to add these two. Negative 3 plus 4 is positive 1. Oops. 1 times 4 is 4. 0 plus 4 is 4. 4 times 4 is 16. Negative 7 plus 16 is positive 9. 9 times 4 is 36. And negative 14 plus 36 is 22, which we'll put in a little box like that. All right, now all of these numbers represent the new powers of x, the answer. So originally we took this polynomial and we removed the x's and just used the coefficients. These are now the coefficients of our answer. If we started with x to the fourth and we divide by x, that means this is going to go down to x cubed is going to be our first term. So this is going to be x cubed. The next one will be x squared, then x to the first, then x to the 0 power, and then our remainder goes with the 22. All right, so when I rewrite that for my final answer, it's going to be x cubed plus x squared plus 4x plus 9 plus 22 over our divisor x minus 4. All right, binomial expansion. So if you remember this one, if you remember how to do that and you want to try it, pause the video. All right, so for this, we're going to need Pascal's triangle. So that looks like this. And we are going to need the row for x to the fifth, which is this bottom row here where the second number is a 5 because we are raising it to the fifth power. So the first thing I'm going to do is I'm going to write out those coefficients. 1, 5, 10, 10, 5, and 1. Now the pattern here, we've got an a term which is x and a b term which is -1. The a is going to start on the left and be raised to the fifth power, the same as this power. And then each term, it's going to go down by 1. So that's going to be a to the fourth, a cubed, a squared, a, and then a to the 0 power goes with the 1, which we just leave as 1. All right, now we'll do the same thing from the other direction for b. So b to the fifth, then b to the fourth, b cubed, b squared, b, and then b to the 0 power. All right, so now we can take those numbers, or we can take those letters, the a's and b's, and replace them with x's and -1s. So this is going to be x to the fifth plus 5x to the fourth times -1 plus 10x cubed times -1 squared plus 10x squared times -1 cubed plus 5x times -1 to the fourth plus -1 to the fifth. At this point, I like to apply all of the exponents to the numbers. I don't really need to apply the exponents to the x's because it's already done, but I want to square this -1. I want to cube this -1 so I can get rid of some of these unnecessary exponents. All right, so the first term, x to the fifth, plus 5x to the fourth, that -1 stays the same, 10x cubed, -1 raised to the second power becomes a +1. 10x squared, -1 to the third is a -1 because it's an odd power. So all of the odd powers will stay negative and all of the even powers will change positive. All right, and now I can just simplify. Those exponents are gone. I can just simplify each term individually. X to the fifth, already simplified. This one, 5x to the fourth and -1 makes it a -5x to the fourth. Then 10x cubed times 1 is just, is 10x cubed. Then the next one becomes a -10x squared. The next one is just 5x and then a -1. All right, last one, long division. See if you got it, and then unpause when you're ready. So this one we're going to have to rewrite 3x minus 5 divided into 6x squared minus 7x minus 5. We'll start out first term divided by first term. So 6x squared over 3x. I'll just do that kind of off to the side here. Gives me 2x. Now I'll take that 2x and I'm going to multiply it by the entire divisor. That's going to give me what I want to subtract here. So 2x times 3x minus 5, and that is 6x squared minus 10x. So 6x squared minus 10x. We'll change the signs, right? So the minus 10 becomes a plus 10. The 6x squareds cancel out. It's negative 7x plus 10x is 3x, and we'll bring down the 5, the minus 5. And now we can repeat that process. So we'll take the 3x, our new first term, divided by 3x, which is equal to 1. And it's a positive 1, so that'll be a plus 1 in our answer. And then 1 times 3x minus 5, that is just 3x minus 5. So that is what we will subtract. And when we do that, everything cancels out, so we have a remainder of 0. And that means that 2x plus 1 is our answer.